Hi, Bessie. So we're going to talk about the emergence of holistic thinking, wherein reality is not only stranger that we conceive, but stranger that we can conceive. So we'll talk about that as we go beyond our discussion. So before everything else, let me introduce you the topics we're going to discuss in these videos. So first is the scholastic paradigm. Next is the Renaissance paradigm. Third is the mechanistic worldview and determinism, the hegemony of determinism, the age of relativity and quantum mechanics, and lastly is the systems age. So let's discuss the scholastic paradigm. In this paradigm, anchored in religion. So pre-scientific era wherein everything is based on philosophy and religion. Explaining stuff is because it's God's will. So for example, why a leaf is brown. So it is because God said that that leaf is brown, is going to be brown, stuff like that. So there aren't other way of explaining things rather than it is God's will, it is what God made. So in this paradigm, salvation is the main viewpoint of life. So science's main goal is to show the connection between the real world and the spiritual world. So we like the end point of everything is that we need to be saved by our creator. So science is only valid if it's supported by religion. So just like what I have said, so if you are going to question when, for example, just like what I have said earlier, that if you question that leaf, for example, God said that leaf is brown, but if you say that based on my experience, on how I experimented on how that leaf on how that leaf ended being brown, you'll be persecuted because that is considered a sin in that time. And natural forces are beyond human control, which is today it is really beyond of our control, since calamities such as earthquakes, typhoon, it's all beyond of our control. But if we are going to survive in that situation, it is because God saved us, because protection came from God. Connection to the reality is informulated, imprecise, implicit, and indeterminate. So just like what I have said, so experiments aren't even a thing in this time because it is considered a sin. So for example, alchemy is to chemistry, astrology to astronomy, and there is the very first concept of elements postulated by Aristotle, which is the earth, air, fire, and water. And the other one is quintessence, wherein the gods are residing in. And psychology is also unknown in this time. So people are being branded like demonic, human, angelic, or divine. So we're going to go through the people who are prominent in this time. So first is Ptolemy, which is an astronomer, and he proposed that the universe revolves around our planet, which is geocentrism. So he said that everything in the universe revolves around us. Next is Galenos, which is a Greek physician which defined on what body fluid is flowing on our body, which is blood, yellow gall, black gall, and slime. And he also said about the type of personality of these fluids. So sanguine, choleric, melancholic, and phlegmatic. So if the bodily fluid is being unbalanced, we're going to be sick. So upset in the balance results to illness. And body fluid and type of personality is strongly connected. So if that is going to be broken, you're going to be sick. So from the previous paradigm, everything is revolving around religion. So there isn't much thing about experimenting because it is considered a sin. So everything is just saying God, God, God. So moving on, we're going to delve into the boom, like the boom of everything, the boom of discovery. So let's get into the Renaissance paradigm. Science became the source of development of technologies. Of course, we could not do technologies if we are going to base it only in what God is saying. So we need to experiment, we need to observe, we need to do a lot of things for us to arrive into a technology for us going to use. So laws of nature is formed on a mathematical basis and deduced from mechanical observation. So they are starting to abandoning it all at once on what the previous paradigm has been practicing. Renaissance or the Enlightenment period, I'm going to highlight the word enlightenment because there is like a light bulb moment for everyone, because since previously they are going to say that that's what God have said, that's what's God's plan, but today they are like, we're going to experiment because I don't think that is right, that is not what is really the truth. And they realized that the world isn't anchored in religion. So various scientists stood up for what is right, despite some of them being killed. So we're going to discuss that there are people who have risked literally their lives in discovering for science. So again, we are apart from religion, and there is the emergence of the universities in this time. Well, though the universities are all from Europe, so universities serves as a haven of neutrality since there aren't any forces from the religion or the state. So people people's interests are being protected here, so they could nourish themselves and be the very person that became the very person they need to be, the best version of themselves. And science nearly died if it wasn't for questioning brought by Galileo and Bruno. I'm going to discuss these two scientists, but just like what have they said, if they haven't questioned things, maybe science have died already, because religion will be very much prevalent in explaining stuff. Religious belief is swiftly replaced by scientific evidences. So first scientist is Nicolaus Copernicus, which is an astronomer. He debunked what Ptolemy have claimed, which is the geocentrism. So he proposed the heliocentrism, wherein the sun is the center of us, the center of our universe. It is the sun, not the earth. And he also claimed that all movements of celestial bodies are in perfect circular motion. Next is Giordano Bruno, which is the one person I have mentioned a while ago, which is a philosopher, and he said that infinite universe and world multiplicity. So there is an existence of world multiplicity, or multiple worlds, multiple universes. But funny thing here is, well, I found it funny, but of course this is a serious thing. Um, the church says that the his claim is very much provocative. Like it's something not to be said. So as a punishment for him, he was burned because of that, because of his claim. So he was burned. Next up are Tycho Brahe, Johannes Kepler, and Galileo Galilei, which are astronomers. So first is Tycho Brahe, which developed new techniques in planetary observation, improving the previous theories. And to mobilize what Tycho Brahe have said, we have Johannes Kepler, which is proving the elliptical motion of planetary objects, which he said in his three laws. And finally, to mobilize more, improving more, what Johannes Kepler have said, we have Galileo Galilei, which invented the very first telescope, having the possibility of having a better look of our planets. And lastly, we have René Descartes. So he is a French philosopher and considered as the very first rationalist, and further expanded the separation between religion and science. So here he said that religion is very much subjective, and while science is more like objective, since we all know that religion is mostly from our mind, whereas science is more like we are going to experiment something, observing something, we are computing something. So it's more of of an objective overview. So in Renaissance period, we have seen that there is a boom of discoveries because a lot of people are being brave enough already to discover new things because previously it was seen as a sin, but now they are being brave to know more about it, to know more about the earth.
Next, we proceed to the mechanistic worldview and determinism. Just to give a short background, in the beginning of 18th century, scientific worldview was established in the European society. Natural phenomena deemed to be investigated and explained. It can be associated to the emergence of rationalism and empiricism as it both dominated the traditional conventions and speculations. Moreover, morality, free will, and thinking were also explained as functions of the organization of matter. Here, reality is determined, examined, formulated, and explicit. It is also when all the mysteries of nature can be explained through mechanistic terms. Based from the readings, during these times, the material world could be treated as dead while allowing man to be the master of this environment. From here, the image of the world was perceived to be like that of a machine, where the goal of science is to dominate and conquer nature. The physical world also was assumed to form a machine that is consisted by sub-functions that could be calculated at events in a certain part of the universe can bring consequences to other parts. It can be correlated with the idea of classic determinism that states to every effect, there is a cause, and to every action, there is a reaction. Cause and effect initiate a chain of interrelated events. This mechanistic era, which can be called as machine age, pertains to the central role played by machines in the Industrial Revolution, according to Lamotry. Next, we proceed to the concept of doctrine of determinism that was discovered. It implies that there is an orderly flow of cause and effect in a static universe, a universe of being without becoming. Superdeterminism was also embraced by many of the scientists of the time. It is the final extreme that states that not even the initial condition of the universe could have been other than it was, because it was determined exactly so by a determinism which determined itself. The general outlook on man also changed and was merely mechanistic. For many, mechanism had come to the logical opposite to superstition. For example, men and animals were in principle nothing more than very elaborate mechanical beings with specific functions to play. Then there is the fact that the world was also separated from the moral world with which it had been one during the medieval era. It pertains to the spiritual and physical order which were synthesized within natural law, which is now seen as a mathematical or physical entity that were still influencing the whole universe. Now, here are some of the important people who had brought great contributions during these times. First is Isaac Newton. He is an English mathematician. He presented a working mechanistic universe that is independent of spiritual order. In Newtonian mechanics, initial condition denotes the material status of the world at the beginning of time, and status changes are then specified in the physical laws. Newton's laws are known that always had a determinism built into them. An example of this is the law of gravity. Next is Pierre-Simon de Laplace. He is a French mathematician. He brought the concept of Laplace demon into context. This demon knows the position and speed of every particle in the universe at any moment. Therefore, he derived at the conclusion that perfect knowledge of the past would give perfect knowledge of the future. Now, we proceed to the hegemony of determinism. It can also be identified as age of scientism, as it was rooted from the belief that only the concepts that can be expressed in the language of exact natural sciences and proven by quantification have a reality. It also encompasses this clockwork universe that works according to the internal structure and causal laws of nature. Here, scientists are presupposed to be outside of the experiment. The observer is not involved. Ideally, the lodestar of the scientist becomes non-intervention, neutrality, and objectivity. It also emerged from the uniform worldview that can be expressed in mechanistic terms. First, it encompasses this clockwork universe that works according to the internal structure and the causal laws of nature. Clockwork was presented as a central characteristic of the general principle of causality, which states that every effect is preceded, not followed, by a cause. Free will also came to the fore as it was claimed to be an illusion. Reductionism also became the predominant doctrine. It encompasses the scientific theories which explain phenomena on one level. Explanations for a higher level can also be deduced. Reality and our experience can be also reduced to a number of indivisible basic elements. Next is the qualitative properties are possible to be reduced to quantitative ones. An example of it is how colors can be reduced to more simpler terms and more simpler ideals. Next is the dehumanization of productive effort and subsequent alienation of the worker gives rise to mental phenomena such as Marxism, Leninism, in a sense that human skills are increasingly taken over by machines, so the remaining manual tasks are broken down into a series of simple and monotonous manipulations. Here, the image of the inevitable death of the universe has significantly influenced philosophy, arts, ethics, and our total worldview. For the generations of researchers here that were nurtured during this bird's mentality, a physical eternity without purpose seemed to be the basis for all reality. Again, here are some of the relevant people who had brought again contributions during those times. First is Auguste Comte, a French philosopher. He proposed the idea of scientific positivism with its demand for hard facts acquired through experience that was brought into fashion. He was remarkable for his positivist mentality. Next is Charles Darwin. He is an English naturalist. He published the theory of evolution by natural selection in The Origin of Species, which is very familiar to all of us. Next, life itself got the conformity to scientific law. We derived that conclusion. And it pertains to the leftover that encompasses pure science, logical, empirical, and with laws for making predictions. Next, we have Rudolf Clausius, James Maxwell, William Thomson, and Ludwig Boltzmann. The mechanistic interpretation of thermodynamics led to new insights. They are responsible for formulating the two main laws of thermodynamics. The total energy in the universe is constant and can thus be neither annihilated nor created. Energy can also be transformed into other forms. Next is all energy in the universe degrades irreversibly.
Now we delve into the age of relativity and quantum mechanics, where scientists, philosophers, and other prominent people look more into the reality of our physical world and introduce new concepts and theories for us to better understand the universe. From the static view of the universe we have as established by determinism, now we have two theories of relativity and the quantum mechanics, which gave another perspective about our physical world. Starting off with the two theories of relativity, we have the special theory of relativity and the general theory of relativity, both developed by Albert Einstein back in 1905. To briefly explain each of them, the special theory of relativity states that space and time cannot be imagined as separate entities, or they cannot be regarded as individual concepts that are not affecting each other. For instance, if an observer is looking at a star from 100 light years away, then this star is also being observed as it was 100 years ago. On the other hand, the general theory of relativity is basically the theory of gravitation. This idea depicts that the content of mass and energy results to a non-flat curving space or time, which as a consequence explains the presence of gravity. We can see this in our own ball of fire, the sun, which curved space or time into a circular orbit in the three-dimensional world. The next theory we have is the quantum mechanics, which revolve around probabilities, putting a halt to determinism. It suggests that everything in the subatomic world doesn't have a definitive structure unless already perceived by the human mind. Observations create consciousness, and consciousness creates material universe. The main points of quantum mechanics are: individual events have no cause, it never explains how something happens, it only lays down the probabilities as to something that should happen. A quantum mechanical event has both non-local and local influence backward in time. It is also stochastic, which means different possibilities are figured out, but precise predictions can never be drawn out of these probabilities. Lastly, it doesn't give explanations or descriptions of a measurement process as these things happen outside time. Next, we discuss the impact of this paradigm to the people during this time. Everything became more confusing, unintelligible, and uncertain. There is more room for free will and spontaneity. Looking back at the Big Bang Theory, which is our biggest effect with no cause, although it has not been entirely proven to be absolute, it is still considered the most verified theory of natural science up to date because many of its components have been supported by existing theories, and therefore there is hope that someday the whole Big Bang Theory may be proven by new theories to be developed through time. Intuition, fact-finding, analysis, and synthesis are the stages in which human knowledge is developed. And synthesis is an important factor in the scientific method since this is the prerequisite for systems thinking. Also, as mentioned earlier, although human experience, observation, and intellect plays a huge role in our perception of the physical world, it doesn't stop there. The innovation of tools and carrying out of experiments aid in further explanation and simulation of those which cannot be solved at hand. Here we introduce the prominent people during this age and expand their contributions to the perception of our physical world. First, we have Albert Einstein, a theoretical physicist, and as aforementioned, he is the one who developed the special theory of relativity and the general theory of relativity in 1905. Next, we have Max Planck, who is a German physicist that enunciated the quantum theory in 1901. He also emphasized that quantum theory should not be understood as a description of the world, but rather it could be used as an instrument for our human mind to be able to make predictions and calculations. Next, we have Werner Heisenberg, who is a German physicist that framed the uncertainty principle in 1927. To quote what he said, "A quantum world does not exist. The only thing that exists is our abstract description of the physical reality." This is another perspective on the role of human intellect in our perception of the physical world, an emphasis on how the observation is dependent on the observant. We also have Niels Bohr, who is a Danish physicist who articulated the complementarity principle in 1927 as well, and stated that physics is only about what we can say concerning nature. Lastly, we have Immanuel Kant, who is a philosopher that expanded that these concepts of space and time were born from human experience. So, as the consciousness has adapted to things, at the same time, things also adapted to this consciousness. This is why the age focuses on probabilities rather than exact claims or viewpoints, since we can only describe what has already been observed and how they happened, but not explain why these events occurred in the first place. Yet, as mentioned earlier, tools and experimentations have been innovated, and this can aid us in further seeing the real structure and origins of our universe. That's it for the age of relativity and quantum mechanics. Now we move into the systems age.
The next and the last paradigm leading to holistic thinking is the systems age. Systems age in which we are now living is the result of the impact of the following 5 revolutions. First, the Agrarian Revolution, or the product of tribes' collective work that extended our food access. Second, the Scientific Revolution, or the product of European collective thinking that extended our knowledge capacity. Third, the Industrial Revolution, or the product of European collective technology that extended our musculature. Fourth, the Electronic Revolution, or the product of global collective technology that extended our nervous system. And fifth, the Computer Revolution, or the product of global collective synthesis that extended our intelligence. The prominent theories, thinking, and concepts in systems age are the following. Systems thinking, often called expansionism, is the answer to the inability of the mechanistic outlook to explain social and biological phenomena. It expands the focus of the observer, whereas analytical thinking reduces it. General systems theory is an attempt to convergence in a world where the unity of science had been lost and different disciplines had drifted apart. Main goal of general systems theory is to formulate generalized systems theories, including theories of systems dynamics, goal-oriented behavior, historical development, hierarchic structure, and control processes, together with working out a methodological way of describing the functioning and behavior of systems objects and to elaborate generalized models of systems. As an applied science, general systems theory became the system science, or a meta-discipline with a content capable of being transferred from discipline to discipline. It is the knowledge regarding knowledge structures and attempts to add and integrate those aspects that seem not to be adequately treated in older science. General systems thinking, the hallmark of general systems theory. It has an aim of fostering generalists qualified to manage today's problem better than the specialist. For general systems thinking, specific individual methods were developed such as systems approach, based on the fundamental principle that all aspects of a human problem should be treated together in a rational manner. Systems analysis, adopting a strictly systemic outlook on complex organizations, entered the scientific scene to ensure that no important factors in the structure were excluded. Anasynthesis was introduced with the implicit assumption that the more views one can apply to it, the better a problem can be understood. It is used iteratively at both the macro and micro levels of large-scale systems. System engineering, a method by which the orderly evolution of man-made systems can be achieved. And system dynamics, which uses dynamic computer models to prognosticate the growth of the modern city, the development of Western industry, and the global resource depletion. General systems thinking can be observed in different perspectives, like in the design or redesign perspective. It is concerned with how things ought to be, with combining resources to attain goals. Systems design or system synthesis, a formal procedure where human resources, artifacts, techniques, information, and work procedures are integrated into a system in order to facilitate its performance. Teleology, the doctrine that behavior and structure are determined by the purpose they fulfill. Systems are guided not only by mechanical forces, but also move towards certain goals of self-realization. Informatics, where the characteristic tools of the domain such as computers, telecommunication networks, and databases are to be found. Science of complexity, wherein biological organization, computer mathematics, physics, parallel network computing, nonlinear system dynamics, chaos theory, neural networks, and connectionisms were brought together. Cybernetics, or control and communication in animal and the machine, is where living systems are studied through analogy with physical systems. Bionics, or the study of living systems in order to identify concepts applicable to the design of artificial systems. Lastly, management cybernetics, system science applied as a problem solver in business organizations. The efforts of management cybernetics are sometimes summed up with the acronym the 7S. These stands for strategy, stuff, style, skills, systems, structure, and shared values.